Ships are designed to survive the ocean. Their hulls are reinforced. Their routes are tracked by satellites. Their crews receive weather forecasts from across the planet. And yet, there are places where size, technology, and experience can all become dangerously inadequate. In these waters, currents collide beneath the surface. Waves grow steeper than expected. Fog hides the horizon. Ice accumulates until a vessel becomes unstable. And storms can transform a navigable route into a moving wall of water. The ocean does not always destroy a ship in one dramatic moment. Sometimes, it removes every safe option one by one. An engine loses power. A vessel begins to roll. A route toward open water disappears. And by the time the crew understands what is happening, the sea has already taken control. Modern navigation has made these regions far safer than they once were. But no technology can make the ocean predictable. These are 8 places where the ocean can swallow ships. Number 8. The Bay of Biscay. A ship can leave the coast of Europe under a quiet sky and enter a completely different ocean only hours later. The Bay of Biscay stretches between western France and northern Spain. It lies open to the North Atlantic, directly exposed to weather systems and long-distance swells traveling from far beyond the horizon. During calm conditions, the bay can appear broad, empty, and almost harmless. But when an Atlantic low-pressure system approaches, the water begins to change. The wind builds across a wide area. Long swells enter the bay from the west. Local waves form on top of them, creating a confused surface moving in more than one direction. For a large vessel, wave height is only part of the danger. The shape and timing of the waves can matter just as much. A ship may climb one swell, while a shorter wave strikes from another angle. The bow rises, the stern loses support, and the entire hull begins to twist under forces moving through thousands of tons of steel. Cargo can shift. Containers can break free. Passengers may believe they are experiencing ordinary rough weather, while the crew is already changing speed and heading to reduce the stress on the vessel. The Bay of Biscay is crossed safely by commercial ships every day, but it remains important enough to appear as its own area in regular marine forecasts, where wind, sea state, visibility, and gale warnings are constantly monitored. Its danger is not mystery, it is exposure. There is little between the bay and the energy of the Atlantic, but the next location shows that an ocean does not need to be wide or deep to become violent. Sometimes, narrowing the water makes the waves even more dangerous. Number 7. Bass Strait, Australia. Between mainland Australia and Tasmania lies a passage that looks small on a world map. Bass Strait is only a narrow interruption between 2 large landmasses. But inside that gap, the sea can become short, steep, and chaotic. The strait is relatively shallow compared with the open ocean surrounding it. When strong winds cross shallow water, the waves can become closely spaced. A ship may rise over one crest only to meet the next before it has fully recovered. Instead of moving through long, rolling swells, the vessel begins to strike the water repeatedly. The motion can be violent even when the waves do not appear enormous from a distance. Tidal currents make the situation more complicated. When a current moves against incoming waves, the distance between the crests can shorten, and the faces of the waves can become steeper. The sea appears to stand up. A wave that might have passed beneath a ship in deeper water can begin breaking across the deck. The Australian Bureau of Meteorology describes Bass Strait as notorious and notes that extreme wave heights occur there frequently. It also warns that opposing tidal currents can increase wave steepness. This combination creates a particular kind of danger. There may be no single giant wave. Instead, the ship faces a continuous sequence of heavy impacts. Each one slows the vessel. Each one places more strain on the hull. And each one makes it harder to keep the bow pointed towards safety. Bass Strait proves that the ocean does not need unlimited space to build destructive water. But farther north, another sea has enough warmth and space to produce something much larger. There, entire weather systems can grow above the water. Number 6. The Bay of Bengal. In the Bay of Bengal, danger can begin as a small rotation in the atmosphere. At first, there may be only clouds gathering over warm water. The pressure falls. The wind begins to turn. Then the entire surface of the bay starts feeding energy into a developing cyclone. The Bay of Bengal is surrounded by India, Bangladesh, Myanmar, Sri Lanka, and island chains stretching toward Southeast Asia. Its northern end narrows toward low-lying coastlines and a broad, shallow continental shelf. This geography can make storm-driven water especially destructive. Strong cyclonic winds push the surface of the sea forward. Lower atmospheric pressure allows the water beneath the storm to rise. As this mass of water enters shallower areas, it can build into a storm surge moving toward the coast. For ships, the danger exists long before landfall. The wind can change direction as the center of the cyclone approaches. Waves arrive from different angles. Heavy rain reduces visibility. Navigation equipment may show the vessel's position clearly, while everything beyond the windows disappears into gray water. A large commercial ship may attempt to move away from the storm. A smaller vessel may not have the speed or fuel to escape. Near the coast, the available sea room begins to disappear. A captain may be forced to choose between heading toward deeper water through worsening waves or remaining near a shoreline being covered by the surge. Modern forecasting allows many vessels to avoid the most dangerous part of these systems. But tropical cyclones can intensify quickly, and their paths are never perfectly certain. In the Bay of Bengal, the ocean does not simply rise. Under certain conditions, it begins moving as part of the storm itself. Yet heat is only one way the sea can take control of a vessel. In the next location, the greatest danger can form directly on the ship. Number 5. The Bering Sea. In the Bering Sea, a ship can become heavier with every wave that strikes it. The water between Alaska and Russia is cold, remote, and exposed to powerful North Pacific weather systems. During winter, strong wind drives freezing spray across the deck and superstructure. The droplets hit metal surfaces and freeze almost immediately. At first, the ice may look like a thin white coating. Then it begins to grow. Railings thicken. Antennas disappear inside frozen layers. Doors become difficult to open. Equipment stops moving. And with every new layer, weight is added high above the ship's center of gravity. This is what makes marine icing so dangerous. A vessel does not need to take water into the hull to lose stability. Ice accumulating above deck can make it increasingly top-heavy. The ship rolls farther with each wave and takes longer to return upright. If the crew cannot remove the ice quickly enough, the angle may continue increasing until the vessel can no longer recover. The problem becomes worse in rough seas. Crew members sent outside to clear ice must work on a moving deck in freezing wind and spray. A single slip may carry someone toward the edge. Machines designed to support the ship may already be buried or frozen. Distance adds another layer of danger. In parts of the Bering Sea, rescue may be hours away. Bad visibility, high waves, and ice can slow the vessels or aircraft attempting to reach the scene. The Bering Sea does not always destroy ships with one wave. Sometimes it builds the weight of the ocean directly onto them. But the next place hides its danger more quietly. There, ships may enter a field of ice without ever seeing what lies ahead. Number 4. The Grand Banks of Newfoundland. The most dangerous object in the ocean may be the one a ship cannot see. The Grand Banks lie southeast of Newfoundland, beneath some of the busiest and most historic waters of the North Atlantic. Here, cold water from the Labrador region meets warmer Atlantic water. The interaction supports rich fishing grounds. It also produces frequent dense fog. The horizon disappears. The sea and sky merge into the same color. A vessel may continue moving at speed while the visible world ends only a short distance beyond the bow. Modern radar can detect many ships and obstacles, but ice is not always simple. Icebergs travel south after breaking from glaciers farther north. Wind and currents move them into the waters near Newfoundland and the Grand Banks. Their shape changes as they melt. Pieces can break away. Smaller fragments may sit low in the water and become difficult to distinguish from waves, especially in poor visibility. The problem is not only collision. A ship changing course to avoid one iceberg may enter the path of another. Fishing vessels may be operating nearby. Wind and current may push the ship away from the route anticipated by the crew. And in a North Atlantic storm, the fog can be replaced by heavy seas without making navigation any easier. The Grand Banks remain actively monitored. Iceberg bulletins, marine forecasts, and reporting systems provide mariners with information that earlier crews never had. But these systems reduce uncertainty. They do not remove it. Out here, a ship can be surrounded by danger while the ocean still appears empty. And farther south, the sea leaves far more evidence of what it has taken. The next coast has earned a name from the wrecks lying beneath it. Number 3. Cape Hatteras. Off the coast of North Carolina, the seabed is filled with the remains of ships that never completed their journeys. Cape Hatteras reaches into the Atlantic beside the Outer Banks, a narrow chain of barrier islands separating the ocean from the mainland. Just offshore lies Diamond Shoals. These shallow, shifting sandbars extend far into the sea, hidden beneath water that may look deep enough for safe passage. A ship pushed onto the shoals can become trapped. Waves strike the hull while the vessel has no room to move beneath them. The ship begins to break against the bottom. But the sandbars are only part of the danger. Near Cape Hatteras, warm Gulf Stream water meets colder water moving from the north. The currents can influence a vessel's route and complicate sea conditions. Then come the storms. Hurricanes approach from the south. Powerful nor'easters develop along the coast. Wind and heavy seas can push ships toward land before the shoreline becomes visible. Historically, vessels followed routes close to the Outer Banks to use the currents and maintain access to coastal ports. That placed them near the same shoals capable of destroying them. The region became known as the graveyard of the Atlantic. Estimates vary depending on the area being counted, and not every wreck was caused by nature. War, piracy, collisions, and navigation errors all contributed. But the natural trap remains clear. Shallow ground lies beside powerful currents on a coast exposed to major storms. A ship fighting the weather can lose the water beneath its keel at the exact moment it needs it most. Cape Hatteras is dangerous because the sea and land work together. The next place removes the land almost entirely. There, storms can travel around the planet with almost nothing to stop them. Number 2. Cape Horn and the Drake Passage. At the southern end of South America, the Atlantic and Pacific Oceans do not meet peacefully. Cape Horn stands above waters leading into the Drake Passage, the gap between South America and Antarctica. To the south lies the Southern Ocean. At these latitudes, powerful westerly winds can travel around the planet with few continental barriers. The distance over which wind blows across open water is known as fetch. In much of the Southern Ocean, that fetch can be enormous. Storm after storm transfers energy into the sea. Long swells travel across thousands of kilometers. new waves form above older ones. Currents and winds reshape them as they approach the narrow passage. The result can be a vast, moving landscape of water. A ship disappears into a trough. The horizon rises into a wall. For several seconds, nothing beyond the next wave can be seen. Then the bow climbs again. Even modern passenger and research vessels can roll heavily here. For earlier sailing ships, the challenge was greater. They depended on wind while attempting to round a headland surrounded by reefs, cold water, and rapidly changing weather. A damaged mast or torn sail could leave a vessel unable to hold its position. Wind might drive it toward rocks or farther into the Southern Ocean. Today, ships cross the Drake Passage routinely. Some experience relatively calm conditions, sometimes called the Drake Lake. Others encounter the far more violent Drake Shake. The route is not permanently dangerous. That uncertainty is part of its reputation. A ship may enter under manageable conditions and discover that the ocean ahead has already changed. But even the Drake Passage is not the final location. Off South Africa, waves face something that can make them rise even more sharply. A current moving directly against them. Number 1. The Agulhas Current, South Africa. The ocean becomes most dangerous when its forces move in opposite directions. Along the southeast coast of South Africa, the Agulhas Current carries warm water rapidly toward the southwest. It is one of the strongest western boundary currents on Earth. Ships traveling through the region may also encounter large swells arriving from storms in the Southern Ocean. When those waves move against the current, their speed changes. The distance between them shortens. Their faces become steeper. Energy is compressed into a smaller area of water. A long swell can transform into a breaking wall. This is one of the mechanisms associated with extreme waves in the Agulhas region. These waves are sometimes called rogue waves. They are not supernatural, and they do not appear from nothing. They emerge from combinations of wind, swell, current, and interactions between different wave systems. But to a ship, the result can feel almost impossible. The surrounding waves may already be large. Then one rises far above the rest. The bow may be driven into the face of the water. Windows can fail. Deck equipment can be torn away. The structure of the ship may experience forces far beyond those created by the ordinary sea around it. In 1980, the supertanker Esso Languedoc was photographed as a huge wave broke over its deck off South Africa. The ship's mast stood approximately 25 meters above average sea level. That vessel survived with relatively minor damage. Other ships have not been as fortunate. The European Space Agency has described the Agulhas Current as a region with numerous well-documented extreme waves and cases of serious ship damage. Modern forecasting can identify dangerous combinations of current and swell. Captains can reduce speed or alter course, but the current itself does not stop. The Southern Ocean continues sending energy north, and where the two meet, the sea can become steeper, faster, and more violent than either force would create alone. This is where the ocean does not need to chase a ship. It makes the water rise directly in its path. The ocean does not hate ships. It does not choose its victims. It follows wind, pressure, temperature, gravity, and the shape of the earth beneath it. But in certain places, those forces converge. A shallow strait makes waves steeper. A warm bay gives energy to a cyclone. Cold spray freezes onto steel. Fog hides drifting ice. Currents push vessels toward sandbars. And one powerful stream can turn an ordinary swell into a wall of water. Most ships cross these regions safely. Forecasts, satellites, stronger construction, and experienced crews have prevented countless disasters. But safety at sea has never meant controlling the ocean. It means understanding how quickly control can be lost. Because a ship may be built to survive the storm. The ocean only has to find one moment when it cannot. This is Dark Atlas.